Hi everyone, I'm Abhisar Ahuja and welcome to the Simplilearn YouTube channel. Today we are going to create a chatbot using Python. And before proceeding, I have an insight for in a file we'll call intents, and that would be the JSON file and the dataset that would contain patterns of words that are associated with different intents or tags. So for that, first we'll create a folder and name it as chatbot using Python. So we'll name as chatbot only. And here we have our intents file. We'll just copy paste into a chatbot. And first, here we'll open a command prompt. And inside the command prompt, first we'll create a virtual environment, because virtual environment is the best thing when you are creating a project. Your libraries won't disturb any of your other project, or any other libraries won't disturb your this project. So to create that, we'll write Python -m env and the name of the folder, or on which name we want to create a virtual environment. We'll create with the name chatbot, and it has been created. You can check here that inside the chatbot folder we have the chatbot, and we have include lib and scripts folder that holds all the Python and its necessary files, that is interpreter and other files. So now we want to activate this. So to activate it, we'll write the name of the virtual environment, then we'll go inside scripts, and after that we'll write activate to activate our virtual environment. You can see here that in circular braces we have chatbot written here. This shows that our virtual environment has been activated, and now we can install any libraries that we want for this project. Now before that, this is the intents.json file. So for this, I will get you guys Visual Studio Code open, and I will show you guys the intents.json file. So this is the intents.json file, which hold the dataset for our chatbot. So this dataset contains patterns of words that are associated with different intents or tags. After that, we will create a file and name it as new.py, and there we will write the code that will pre-process this data by tokenizing, lemmatizing, and removing stop words. Then we will create a bag of words that will represent the data, which is used to train a neural network model. The model has 3 layers, with the first layer being a dense layer with 128 neurons, and the second layer being a dropout layer, and the third layer being a dense layer with the number of neurons equal to the number of intents. Then this model will be compiled with the stochastic gradient descent, that is SGD optimizer, with a learning rate of 0.01 and momentum of 0.9 and Nesterov acceleration. The model is then trained with the training data for 200 epochs, and the trained model is saved in a file that will name chatbot model. So first we'll start with the JSON file. You guys can see the JSON file. I have updated some dataset here. I will just upload this file on the GitHub page, and you can download it if you want to use this also. Now moving on. Now we will create a file, and we'll create the file inside this chatbot, and we'll name it as new.py. And inside this file we will perform all the other operations, that is tokenizing, lemmatizing, and removing stop words. And before that, the first thing we need to do is we need to install and import libraries, as we have created the virtual environment and we don't have any libraries, that is instead of built-in libraries installed into our virtual environment. So we will install the necessary libraries for our virtual environment. So here we have created the JSON file, and that has all the possible outcomes of user interactions with our chatbot. We first need a set of tags that users can use to categorize their queries. These tags include name, age, and many others. Every new tag would require a unique new pattern, as we have the tag goodbye, thanks, query, greetings, and these are the patterns, and these are the responses that our chatbot would give us. So identifying these trends can help the chatbot train itself on how people query about a chatbot's name, allowing it to be more responsive. The chatbot will return pre-programmed responses, that are these responses. And now we'll start with installing and importing libraries. So for that, we'll get back to our command prompt in which we have activated the virtual environment. And the first library we need is NumPy. So for that, we'll write the command pip install NumPy. And here we are collecting the data. And if you want, if you want to know the command to install these libraries, you can just go to your browser and you can open a new tab, and there you can write the name of the library, that is NumPy, and then you can write PYPI, that is the pip website to install any library. So it will show you the command to install the libraries. Here we can see that NumPy is installed. Now we'll install TensorFlow. So for that we have written the command pip install TensorFlow. So it's downloading, and you can see that it's being installed in our virtual environment that we have named as chatbot. I can show you guys how to get NumPy PYPI. So this is the website. You can just click on that and you can see the command to install the particular library. Similarly, you can do for TensorFlow, and the next we will install is NLTK. So we'll wait till it installs. Now the TensorFlow library has been installed. Now we'll install the NLTK. So for that, we'll write the command pip install NLTK and press enter. So now it would be installed. Is installed. Now we'll come back to our IDE, and I'm using Visual Studio Code as you guys have seen it. You can use any that you have hands on. And now we'll start with importing the libraries, and we'll import required modules such as random, JSON, pickle, NumPy, TensorFlow, and NLTK. And we'll import WordNet lematizer class, that is from NLTK.stem module, and we'll initialize an instance of the WordNet lematizer class, and we'll load the JSON data, that is from the intents.json file that you guys have seen, that we have stored the dataset into that, and we'll store it in a variable and named as intents. So we'll start with importing. First we'll import random, and after that we'll import JSON, and after that we'll import pickle. Sorry, I have written pickle. Import pickle, and after that we'll import NumPy as NP, and after that we'll import TensorFlow as TF, and here we'll import NLTK, and from NLTK.stem we'll import WordNet lematizer. Okay, now we have imported the JSON file that is used to utilize the work with JSON data. Then we have random, that is for various distributions, and this module implements pseudo random number generators. And the word net lambdizer, it can lambdize. And TensorFlow, it's a multi-dimensional array of elements that is represented by this symbol. Now we'll create a variable that is lambdizer, and that will initialize it. And now we'll create a variable for to load the intents.json file. So we'll name it intents, and we'll use json.loads to load it. And inside we'll use open and intents.json, and we'll try to read it. Okay. Now we'll initialize empty lists, that is for words, classes, and documents. And now we'll also create a list of characters to ignore, that would be also initialized into a list. So we'll initialize lists. For words we have initialized. Now for classes, and after that we'll do for documents, and now we'll create a list for ignore letters. So inside this we will write what we need to ignore. Okay, so slash question mark and exclamation mark, these would be neglected from a data set, that is JSON file, period, and the comma. So these would be neglected. Now we'll loop through the intents and their patterns, and after that we'll tokenize each pattern into a list of words using NLTK.word_tokenize. That is, if we open the JSON file, you can see the tags, patterns, and responses. Now, and after adding each word in the word list that is we have created, then we'll add a tuple containing the word list and the intent tag to documents. Then we'll add it into the documents. And if the intent tag is not already in classes, we'll add it to the list. If the intent tag is not already in classes. So I'll show you how we'll do it. So for intent, in intents, and for pattern, in intent, and inside we'll pass patterns. We will create a variable and name it as word list, and that would be equal to NLTK dot, we'll use the word underscore tokenize to tokenize it, and inside we'll pass the pattern. After that we'll use words dot extend, and inside we'll pass word list. And now we'll append the documents, that is we'll add a tuple containing the word list and the intent tag to documents. So for that we will append it, that is documents dot append, and inside we'll pass word list and intent tag. Okay, and now if intent tag not in classes, that is if it's not present in classes, then classes will be appended, and they would be appended by tags. Okay, now we will lematize each word in words using wordnet lematizer, and we'll remove the characters in ignore letters from words. That is, if there is ignore letters present in any of the word, we'll remove them. And then we'll sort the words in alphabetical order and removing duplicates using set. And after that, we will be sorting the classes in alphabetical order and removing duplicates from set. And after that, we'll pickling the sorted words and classes list and saving them to files called words.pkl and classes.pkl respectively. Okay, so for that, first we'll lematize each word in words using wordnet lematizer. So for that, we will create a variable and name it as words, and here we'll use lematizer and create a list for that also, lematizer, and we'll lematize, use the lematize function, and inside we'll pass word, and for word in words, name word not in ignore letters, that is if it's not present in ignore letters, we'll sort it out. So ignore G showed no. That is we have named it ignore letters. Okay, and inside this, now we'll sort this, that is words equal to sorted, and inside we'll create a set, and inside we'll create classes. Okay, now what we'll do in classes is we will sort the classes only, that would be in set, that is if there are any repetitions, that would be eliminated and it would be sorted. So we'll sort the classes in alphabetical order and we'll remove any duplicates. If there are present any duplicates, they would be removed. Now we'll use pickle and we'll use the dump function, and inside we'll pass words, and we'll open save words.pkl. V, and the next we'll do is pickle.dump, that is we'll pickling the sorted words and classes, that would be classes list, and saving them to files, that would be words.pkl and classes.pkl. Okay, so now we have done for the words, now we'll do for the classes. So for that we'll write pickle.dump, and inside we'll pass in which we want to save them. So first we'll pass the classes, and after that we will open classes.pkl, and inside we'll write wp. Okay, and now we'll initialize an empty list that would be called training, and after that we'll create a list of zeros with length equal to classes and sort it in a variable called output empty, and looping through each document in documents, and we'll initialize an empty list called bag. After that we'll tokenize each word in the document and lemmatizing it using wordnet lematizer, and we'll create a bag of words representation of the document by setting the value of each word in words to 1 if it happens in the document and 0 otherwise. So to do that, we'll start by creating a training list. Okay, and after that we'll write output empty into length of classes. Now we'll run a loop, that is we'll check in the document. For document in documents we'll create a bag and word patterns, that is document and word patterns equal to lematizer dot will lematize, and that is word dot lower. Okay, and now for that we'll write for word and word patterns now I'll run a for loop, that is for word in words, and will append in bag, that is bag dot append, and will show output row, and before output row we will bag dot append 1 first, that is bag dot append 1, and that is if word in word patterns, else will bag dot append 0. Okay, we have done this, bag dot append 0. Now what we'll do is we'll create a variable and name it as output row, and inside we will create list, and that would be we'll pass output empty. Okay. Okay. uh, so now here we have created output row, and now inside output row it will passes classes, and that would be the index and the particular document. Okay, and that should be equal to 1, and after that, if it's there, then we'll append it, training.append, and inside back plus output row. Okay. And after that, do random dot shuffle, and we'll pass training inside that, and training equal to np dot array, and inside we'll pass training. After that, we'll create a trainx, and inside we'll pass training colon length words trained by, and in this we'll create a training list, and inside we'll pass colon and the length of words. Okay. Now we have created this. We have created a bag of words for the representation of the document by setting the value of each word in words to 1, and if it appears in the document, and we have set it 0 otherwise. And now we will create a new sequential keras model, which is a linear stack of layers. For that, we'll write model equal to tf dot keras dot sequential, and after that we'll add a densely connected neural network layer to the model. This layer has 128 units, and the input shape is determined by the length of the first training example. The activation function used in this layer is ReLU. So I will show you how to add this. We have added the model. Now in the model we'll add, and for that we'll write tf dot keras dot layer, and that is the dense layer, and inside we have 128, and we'll input shape that is equal to length of trainx, okay, and what will pass is, okay, we have this x 0, this, and here we will have activation, and that is of ReLU. Okay. Now we'll add a dropout layer to the model, which will randomly set 50% of the inputs to 0 at each update during training to reduce overfitting. So to do that, we'll write model dot add tf dot keras dot layers, and which layer will drop out. Okay, and pass 0.5, that is 50%. Okay, it will set the inputs to 0 for the 50% inputs. And now we'll add another densely connected neural network to the model, and this layer will have 64 units, and the activation function used in this layer will be ReLU. Okay, so for that we'll add model.add, and inside we'll pass tf.keras.layers, and we'll use the dense one, and inside we'll pass 64 and activation equal to ReLU. Okay, that is done. And now we'll add another dropout layer to the model with the same configuration as the previous one, that is model.add, and inside pass tf.keras.layers, and this would be the dense layer, and inside we'll pass length of train y 0, and set the activation equal to softmax. So this adds a final densely connected neural network layer to the model. This layer has a number of units equal to the number of unique classes in the training data, and the activation function used in this layer is softmax. Softmax ensures that the outputs of the layer represent a probability distribution over the possible classes. So now we'll create a stochastic gradient descent optimizer with a learning rate of 0.01 and momentum of 0.9 and a stroke momentum enable. So for that we'll write sjd equal to tf.keras.optimizers and .sgd, and inside we'll write learning rate, that is equal to 0.01, and we'll set the momentum, that is 0.9, and Nestrov, that is equal to true. So now we have created a SGD. Now we'll compile the model specifying the loss function as categorical cosentropy, the optimizer as the SGD optimizer created earlier, and the metric to be used to evaluate this module as accuracy. Like, to evaluate this model as accuracy, we will compile the model. So for that we'll write model dot compile, and inside we'll pass loss equal to categorical cosentropy, and we will set the optimizer equal to SGD. Okay, and metrics equal to accuracy. Okay, now this will train the model, and now mainly to train it we'll create a variable and name it as hist, and to train this model using the training data, for 200 epochs with a batch size of 5. The verbose parameter set to 1 specifies that progress messages should be printed during training. The training data is passed as numpy arrays to the model's fit method. So for that, we will create a variable and named as hist, and inside we will pass model dot fit, and inside we'll pass np dot array, and inside we'll pass train x and np dot array, and inside we'll pass train y and epochs equal to 200 and batch size that will set as 5 and verbose equal to 1. Okay, so now we'll save the train model to a file and name the file something. So we'll say what we'll name it. So to save this model, we'll write model dot save, and we'll write the name of this model as chatbot underscore Simplilearn model dot h5. Okay, and we'll pass hist. So this will save the train model to a file that is named chatbot underscore Simplilearn model dot h5 along with the training history. So as this would be done, we want something to print. We'll print executed. Okay, so this will simply print the executed to the console to indicate that the model has been trained and saved successfully. So we'll save this and run it. So we'll see if there is any error or not, or if our model is executed successfully. So we'll wait for it. Okay, so here you can see that it has shown that it's running in virtual environment. We have run it again. Let's see, it has shown us some errors, but we'll wait for the execution once again. Yes, so in 45th line, okay, so this will be in brackets. Okay, and yeah, for this, okay, we'll save this and run it again. Open the terminal again and run it again. So we have a new terminal here and we are executing the file. So you could see it is downloading the models and it has printed executed. So our model is running fine. So now we'll create another file and name it as chatbot.py. For that we'll create a file chatbot.py, and here we'll execute the functioning of chatbot and what it will provide us back. So before that, I will give you a quick recap of the new.py file. So this new.py file is an implementation of a simple chatbot using Tensorflow, which is a machine learning framework developed by Google. And the chatbot is trained using a neural network to classify user inputs into predefined intents and provide appropriate responses based on the detected intent. And the code starts by importing the necessary libraries including NumPy, TensorFlow, and NLTK. The word net lemmatizer from the NLTK library is used to reduce words to the base to improve classification accuracy. That is called lemmatize. The code also loads the intents.json file, which contains the predefined intents and associated patterns and responses. Now, the code then prepares the data for training by iterating through each pattern in the intents.json file, tokenizing it into individual words, lemmatizing the words, and adding them to a list called words. And each pattern and its associated intent are also added to a list called documents. Additionally, a list called classes is created to store the different intents. Next, the words list is cleaned by removing any punctuation characters and duplicates, and then sorted alphabetically. Similarly, the classes list is sorted. These cleaned and sorted lists are saved to files called words.pkl and classes.pkl, respectively, using the pickle library. And the code then iterates through the documents list and converts each pattern into a bag of words, that is a list of binary values indicating whether each word in the words is list is present or not in the pattern. The corresponding intent for each pattern is also converted into a one-hot encoded vector indicating which intent it belongs to. These bag of words and one-hot encoded vectors are then combined and added to a list called training. The training list is then shuffled randomly to ensure the neural network does not learn any order dependencies in the training data. Finally, the training list is converted into a NumPy array and split into separate arrays from the bag of words, that is train X, and one hot encoded vectors, that is train Y. You can see them. And the neural network is defined using the TensorFlow sequential API, which allows the layers to be added in the sequence. The neural network consists of three fully connected layers, the first with 128 nodes, the second with 64 nodes, and the third with a number of nodes equal to the number of classes. The first two layers also include dropout regularization with a dropout rate of 0.5, which helps to prevent overfitting. The model is compiled using stochastic gradient descent, that is SGD, as the optimizer, and categorical cross entropy as the loss function. The accuracy metric is also calculated during training. Finally, the model is trained for 200 epochs with a batch size of 5 and verbose set to 1 to display progress during training. After training, the model is saved to a file, that is chatbot_Simplilearn.h5, along with its training history, and the program prints execute to indicate that the training is complete. Now we'll move to chatbot.py, and inside this file, first we'll import the necessary libraries to run the code. And the necessary libraries here are random. First we'll import random, and after that we'll import JSON, and after that we'll import pickle, and then showing error in JSON. No, okay. We'll import NumPy, S, and P, and after that we'll import NLTK. And now from NLTK.stem we'll import word net lematizer, okay. Now from keras.models we'll import load underscore model, okay. Now we have imported these, that is load underscore model. So random is used for generating random responses from the bot, and JSON is used for reading the intents file in JSON format. Pickle is used for reading the words.pkl and classes.pkl files, which are pickled Python objects. NumPy is used for creating arrays, and NLTK is used for natural language processing, and word net lematizer is used to lemmatize words. Load underscore model is used to load the pre-trained chatbot model. Now, create a variable and initialize the WordNet lemmatizer. And after that, we'll create an intents file and load the JSON file, that is intents.json file. For that, we'll use json.loads, and inside we'll open the file, and here we'll name the file, that is intents.json, and after we'll use the read function to read this file. Now we'll create a variable and name it as words, and inside we'll load the words.pkl file using the pickle library. That will write pickle.load, and inside we'll open the file, that is words.pkl, and pass r, and after that we will load the classes file, and that is pickle dot, we'll just copy it and change it to classes dot pkl. Okay, now load the model, that is load underscore model, that is the pre-trained model, and we have set the name of the model as chatbot underscore Simplilearn model.h5. So we'll copy it and get back to a chatbot.py file, and inside loads.model we'll paste it. So this initializes the lemmatizer object that reads the intents.json file and loads it into a Python dictionary using the JSON library. The words.pkl and classes.pkl files are loaded into Python list using the pickle library. And finally, the pre-trained chatbot model is loaded using load underscore model. Now, what we'll do is we'll create a function, and that function will take a sentence as input, tokenize it using NLTK dot word underscore tokenize, lemmatizes each word in the sentence using the lemmatizer object, and returns a list of lemmatized words. So for that, we will create a function and name the function as cleanup sentence. Okay, and in that we'll pass the sentence, and now we'll create a variable sentence words, and inside this variable we'll use tokenize and pass the sentence to tokenize it. For that we'll use NLTK dot word underscore tokenize, and we'll pass sentence, and after that with the same variable we'll lemmatize it. So to lemmatize it, we'll use lemmatizer dot lemmatize, and inside we'll pass just a second, is there any error? Okay, word underscore tokenize, and in the lemmatize we'll pass the word, and for word in sentence words what will return is lemmatizes sentence words. So we'll return sentence underscore words. Okay, so we have done that, and now we'll create a function that takes a sentence as input, calls the cleanup sentence function to get a list of lemmatized words, then creates a bag of words representation of the sentence and returns it as a numpy array. The bag of words representation is a binary vector that has a 1 in the position corresponding to each word in the vocabulary that appears in the sentence and zeros elsewhere. So for that, we will create a function and we'll name it as bag of words. And inside we'll pass the sentence. Okay. Now we'll use the same variable sentence words, and here we'll call the cleanup sentence function. And inside we'll pass the sentence. Okay. And now we'll use bag variable and the 0 position into length of words. And now we'll run a loop for sentence words, that is for w and sentence underscore words, and in this loop we'll enumerate the whole words, that is for I comma word and enumerate, and we'll pass words here, and inside if word equal to w, then bag of I equal to 1 else, and here we'll return the array with the, so it's return, and that is np dot array, and we'll pass bag here. Now we'll create another function that takes a sentence as input, creates a bag of words representation of the sentence using the bag of words function, feeds the bags of words representation to the pre-trained chatbot model using model.predict function, and returns a list of intents with the probabilities, and the error underscore threshold variable that we'll create that will set the minimum probability required for an intent to be considered. The list of intents is sorted in descending order of probability, and each intent is returned as a dictionary containing the intent. So for that we will create these functions, and we'll start with the function predict class, and inside we'll pass sentence, and here we'll create a variable and named as bow, and inside we'll call bag of words function and pass the sentence, and after that we'll create a variable res and use the model to predict, use np.array, and inside we'll pass vow and its 0th position. Okay, and after that we'll set the error threshold equal to 0.25, and we'll make it in capital letters only. Okay, threshold that is equal to 0.25. Okay, now we will create a variable and name it as results, and inside we will pass a comma r, that is for I comma r in enumerate, and we'll pass this, and that is if r is greater than error threshold. Okay, and if that's the case, then we'll sort it. We'll sort the results dot sort, and inside we'll pass key equal to lambda x, and that is position 1, and reverse equal to true. Okay, and return underscore list, that is, and for r in results, return list dot append, will append, and inside of intent and classes are and probability that is str side r of 1, and the brackets are closed, and after that we'll return underscore list. Okay, and after this we will create another function, and that will be get response, and this function will take two parameters, intents underscore list and intents underscore json, and this intents underscore list that will contain the predicted intents of the user input, while intents underscore json contains a json file that lists all the possible intents and their corresponding responses. The function then matches the predicted intent with the intent in the json file, selects a random response from the list of responses associated with the intent, and returns it as a chatbot response. Okay, so for that we'll create another function, and we'll name it as get response. And inside this we'll pass intents underscore list and intents underscore json. Okay, and after this we will create a variable named as list of intents, and in this pass intents underscore json, and inside intents, and we'll also create a variable tag, and inside this we'll pass intents underscore list, the 0th position, and okay, with intent only. Okay, now we'll run a loop, that is for I in list of intents if I equal to tag and result equal to random dot choice and okay, random dot choice. Okay, and inside we have responses, and after that we'll break, and then we have the result, that is we'll return the result. Okay, and after that we'll print that great bot is running. And you can remove that also. And after this, the main program will use an infinite loop that waits for user input through the input function. And once the user enters a message, it calls the predict underscore class function that is not shown in the code to predict the intents of the message. It then calls the get underscore response function to retrieve the appropriate response from the JSON file and prints it as the chatbot's response using the print function. So first it will call the predict underscore class function. So for that we'll create a loop while true message equal to input and have create ints, and this is the predict class function, and inside we'll pass the message, and in the ice variable we'll call get response, and inside we'll pass ints and intents, and after that we'll print res. Okay, now we are completed with the code, so we'll save it and run it. So we are waiting to it get executed. Stop the terminal and execute it again. Okay, now it has shown the virtual environment, so we'll run it again. Okay, so in line 10 it shows some error. What is a type error? Okay, takes no argument. We'll see that. So, okay, it will not take any, we are just initializing it, so we'll run it again. So you can see that a code is executed and it has printed great bot is running. So we'll ask, hi there, hi there. Okay, and we'll just, okay, we have to run it again. And there is a get what is running, so we'll write hi. Okay, if there is some error, just cut this file. Got this intents.json file inside this chatbot only, and we have done that. Now we'll run it. Terminal, and now run it. Oh, sorry, we are running the intents.json file. That's why it's not happening. Run the chatbot.py. And okay, it says there is an error in 12th intents.json. Okay, I don't see any error in this. Okay, once see if there is any error. Okay, so it's showing error. So what we'll do is we'll copy the path of the intents.json file and run it. So for that we have come here, we'll copy the path, get back there, paste the path and slash intents.json file, and now we'll run it again. Now you can see that the file is successfully executed. First, like without path also it has been executed, and the file is in the same directory. It should be, but it was showing error, so we have done that. And we'll do the same for the chatbot.py, and here also we'll copy the same path, slash intents.json, save it and run the chatbot. Now you can see go bot is running. We have written great or go. It has changed. Okay, no worries. So we'll same hi, and he respond us to good to see you again. That is from the intents.json file. He is giving us the random responses. So this is our intents.json file, and from here, like if we say him greetings, that is patterns hi or how are you, he has selected good to see you again and it has responded us. That is, he is using the random function. Our chatbot is using random function, and if we say him bye or will same thanks, he is saying good to see you again. Thank you. Now he's saying you are welcome. So I don't know why he said good to see you again and thanks. See, thanks for helping me. There's only my pleasure and you're welcome. I don't know, like, is there any error? I will ask him what is Big Bang. Okay, he's responding correctly now. Maybe there could be a slight error. in the pre-processing. So no worries, our code is running fine, and I will update all these files, that is intents.json file, chatbot.py and new.py, into the GitHub repository. You can download it from there. You can create your own chatbot and you can provide data to it. That is, you can provide other tags and the patterns that you will inquire him and the responses accordingly. So here we have done with our project, and with that we have come to the end of this session, and I hope the session was interesting and informative. If you liked it, please let us know in the comment section below. Also do subscribe to our channel and stay tuned for more from Simplilearn. Till then, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.